Does everybody understand that? And as sly as you think you might be, I can detect if you've used AI. So don't. Everybody got that? Okay. Any questions about any of these problems? Like I've said before, you don't need to be a super expert. You need to be able to do about 2/3 of the problems from 5.2 and 5.4, okay? Okay. Thursday, I want you to bring in all the problems that you're not sure that you did right for me to check. And or you can say, well, look, I was trying to do this problem in 5.2 and I got stuck, right? How do you do this, right? And by the way, I've done all of the odd problems, so it should mostly be even problems that you're asking me about. Okay, does everybody understand that? And the test will be posted on Thursday. So this is what I want to do now. There were a lot of people who are misusing the rules, okay? So if you feel very comfortable, like you aced this quiz, you're free to leave early. Those who are like shaky on this, you stay behind and I'm going to review the rules again, right? And then Thursday in class, we'll be using the rules again. And also, look, usually no one comes to my Friday morning office hours, right? You should really think about coming this Friday. I don't know when they are, from 8 to 12 or 9 to 12. One of those two. That's your last chance for help on this test. I won't answer test questions directly, but if you're smart enough, you can ask a question that's analogous enough to help you sort through crap. Does everybody understand that? So, look, I'm going to be sitting in my office on Friday morning, and actually, if a whole bunch of people come up, I'll leave a note and we'll come to a classroom. So we have a big board to work on. Does everybody understand? So that's your opportunity if you're feeling lost. But also remember this, when you're doing the test, never leave it blank, okay? Always do some junk. Make sure that it's legal, okay? Because what I do is I can give you half credit for not answering the problem, but doing a bunch of legal stuff, although you couldn't find your way to the conclusion, right? But as soon as I see an illegal move, it's over, right? That's a 0, unless you've gotten up to, let's say the proof is 8 steps. I want to see at least 4 legal steps on the way, even if you don't find the solution. Does everybody understand that? And then you can get half credit. But if you have an illegal move before you've gotten halfway, as it were, no. Everybody got that? So don't leave a problem blank, but make sure everything you do is legal. Okay? Any other questions right now? Okay. So those who are very comfortable with the chapter, you're free to skedaddle. Otherwise, stay behind, and I'm going to go over all the rules and make sure we understand them. And then on Thursday, we'll be applying those rules again. Everybody got that? Okay, so let me erase the board. Those that are taking off can take off. Those that are staying can stay. And we'll go through these rules. And I'm going to go through the rules of inference, and then I'll go through the rules of replacement. And we'll fill up this entire board. first rule that we're going to talk about is modus ponens. Okay, if I have a conditional, this says if you have a box, then circle. So suppose I have a box. What follows from these two things? Circle, right? If you have this, then you get that. Well, I have it, so I get it. Okay? And look, modus ponens only works for conditionals. You can't have something like this, box or circle, box, and then say circle modus ponens. No. That matters, right? It's only for conditionals. Everybody got that? Now, also, this eraser. Remember, those shapes are variables. So they can represent a single statement or a complex statement, a negated statement, whatnot. So look, here's a very simple instance of modus ponens. P, then Q, P, therefore what? Q, okay. Remember, it's just, if we have a substitution instance of these, we get the substitution instance of those. So this could be not P, then not Q, not P, therefore what do I get?
Not Q.
Not Q, right? Does everybody understand that? Because think of this as the box, that is the circle, this is the box. So what do you get? Circle. What's the circle? Not Q. Everybody got that, okay? And then to generalize it more, remember, this could be a single statement constant or an expression, so I could have B if and only if J, then not Q. B if and only if J, what do I get?
Not Q.
Not Q by modus ponens. Everybody understand that? And look, all you need is one of these and one of those, and you get one of those. So they might be separate. They don't have to be right next to each other in the premises. Does everybody understand that? Okay. Just so long as you have one of these and one of those, you get one of those by modus ponens. Okay? And modus ponens is only for conditionals. Okay? All right. Now, modus tollens. Okay? So we have the box, then circle. We have the opposite of the consequent. Okay? That gets us the opposite of the antecedent. Okay? So these are opposites, and that gives us an opposite of the antecedent. Okay? So P then Q, not Q, therefore not P. Does everybody understand how that works? Opposites, opposites. Okay? And it's the opposite of the consequent. It doesn't matter if you have the opposite of the antecedent. That doesn't get us anything. Does everybody understand? Opposite of the consequent gets us opposite of the antecedent. So if I had not P then, not P then not Q, and I had Q, what would I get?
P.
Correct. Did everybody see that? Opposite, opposite. That's modus tollens. Okay? Any questions about that? So it's only for conditionals, and you must have the opposite of the consequent of the conditional to get the opposite of the antecedent of the conditional. Okay? So I discovered the other day that one student I was working with, when I said in those words instead of these shapes, that would made it more concrete for them, which seems a little bizarre to me. But so I'm going to listen to how I describe it other than just the picture, because that might make more sense to you. Okay. Next up is hypothetical syllogism, and this works only with two conditionals, okay? So suppose I have box, then circle, and I'm gonna put it like this, circle, then triangle. You can get box, then triangle. Just think about it, it's like, if this, you get that, and if that, then you get this. So if you start out with this, you're going to get that, okay? And this is hypothetical syllogism, okay? So this is a way of creating a conditional that you might not otherwise have. Now, remember that these are conditionals and these are variables, so I could do this, not P, then Z and F, and I have Z and F, then Q. What do I get from these two?
not P and Q.
Yep. Does everybody see that? Think of this as the box, think of that as a circle, that would be a circle, this would be something new, call it a triangle. So not P, we called a box, and Q's we called a triangle, and that matches this exactly. Everybody understand that? Okay, good. So that's hypothetical syllogism. And look, so long as you have this and so long as you have that, let me move this over so it looks better. Triangle, box, then triangle. As long as you have one of these and as long as you have one of those, you can get one of those. And sometimes you might see this one in the premises before that one. Does everybody understand that? And so you mentally have to shift them to see, oh yeah, I can get this, right? So the pattern is two conditionals, the consequent of one matches the antecedent of another, and then you can create a conditional, the antecedent